Let us talk about power function. The power function of a statistical test tells us how good the test is at detecting the true effect when there really is one. In other words, it is the probability that test will correctly reject a false null hypothesis. Now imagine a scenario in which you are trying to figure out if a new drug works better than the old one. You start with a null hypothesis, which says that there is no difference when compared to the old drugs, while the alternate hypothesis says that the new drug is better. So, when you will perform an experiment to compare the drugs, there can be two possible outcomes. The first is that you reject the null hypothesis. This means that you believe the new drug is better. And second is that you fail to reject the null hypothesis. This means that you believe that there is no difference between the true drugs when you compare with that of the older one. So the power of the test is the chance that the new drug is better. Your experiment will successfully show that. If the test has higher power, it is more likely to detect a real difference when one exists. Let us consider one example for this case. Suppose you are testing a new weight loss pill. The null hypothesis says that the pill doesn't help with weight loss. If the pill actually does help, a test with higher power will be able to detect and show the pill works. If you test 10 people and see a small change, the test might not have enough power to prove that pill is effective. But if you test with more number of people, say 100 people, the large sample gives more power, making more likely to detect the effect. So basically, the power function shows how this probability change depending upon how strong the true effect is. For example, in this case, how much weight people actually lose and the size of the sample. Now let's look the code regarding the same, regarding the effect of power function. So the first line is used to perform statistical calculation. Here we import the NumPy library, and then this is the for creating plots and visualization. Next, we assign the null hypothesis mean, here in this case 100, then the standard deviation, here in this case, which is the root of 20, and then here we create an array of 50 values between mu0 and mu plus 6, which is used as a possible true mean values. So these are the two sample size used in the comparison. C1 and C2 are critical values for the hypothesis testing at the 95% confidence level. So which is 1.645 is the z square z score for one tail test at this level. The formula is adjusted by dividing sigma by the square root of sample size n1 and n2. The next is the power function calculation. So here we are estimating the cumulative distribution function of the normal distribution. So here eta 2 and eta t, eta 1 and eta 2, these represent the power function of the two different sample n1 and n2 computed by taking 1 minus the CDF of the distribution of the test statistic. It gives the difference between the critical value and the true mean mu. And then here we plot the function, power function. So if you run the plot, you will see that we have two values for. So this is the This orange one is for n is equal to 10, and then this one is for n is equal to 50. This orange one is for n is equal to 50. This blue one is for n is equal to 10. So here you can see that as we have increased the sample size, uh, the power function has increased in this case. So this means that it is basically satisfying this criteria. Okay, this we are basically rejecting the null hypothesis, and we are also seeing the effect of this also, that if we increase the sample size, the larger sample will give more power, making it more likely to detect the effect. Okay.